In this video, we're going to look at medians of a triangle. A median is the distance from a vertex to the midpoint of the opposite side. We can construct a median at all three angles of a triangle. Your medians will all intersect at a point, and that point is called the centroid. Okay, let's go ahead. I'm going to get this sheet out that we did if you remember, in the last lessons, we found the altitudes of an acute triangle to find the orthocenter, a right triangle to find its orthocenter, and an obtuse triangle to find its orthocenter. So now what we're going to do is we're going to switch to finding the medians and seeing if we can find the centroid for each one of these triangles. Okay, so in order to do that, I'm going to need to get a ruler so that I can measure my side lengths so I can find the midpoint. So let me zoom in. Oops, zooming in, not out. So that we can measure and see if we can find our midpoints. Okay. All right, so when I look at this first one and I go to measure, I can see, and I want to try to be as exact as possible, this is probably about 5.8 centimeters. So if it's 5.8 centimeters, and I want to know what exactly half of 5.8 centimeters is, 5.8 divided by 2 is 2.9 centimeters. So 2.9 centimeters is going to be almost at 3. Right here. Okay? And I'm going to mark this as a midpoint here and here. And I can even write that this is 2.9 centimeters and this is 2.9 centimeters. Okay? Then I'm going to connect from the opposite side to that midpoint. So notice this is not going to be an altitude, right? Because an altitude would have to hit at 90 degrees. Okay? So it's not an altitude. This is definitely different. So it is a median that goes to the midpoint. Okay, so that's my first median. Again, we can do that to each side. So if I measure this one is about 4.1 centimeters. 4.1 centimeters, and when I divide that in half, 4.1 divided by 2 is 2.05. So that one's a little tricky. 2.05 is halfway between the 2 and the first tick mark right after it. So it's right in between there. Okay, 2.05 centimeters. 2.05 centimeters. There's a decimal there. And since it's different from this one, I'm going to put different matching marks. I'm going to put a double mark on that one because it's different. If they were the same, I could use the same mark. Okay, so now here I want to connect the midpoint from this side to the opposite corner, the opposite vertex. I should use good vocabulary. Okay. All right, so then we have one more side to measure. When I measure this last side, it looks to me to be about 6.2 centimeters. So that's going to be 3.1. It's going to be right here. And then we can see how good of a job I did measuring. 3.1 centimeters. So then when I connect it, we'll see how close I get to making it work. I didn't do too bad. That's pretty good. They intersect pretty close. There's a really easy trick. If yours kind of has a little gap in there that you're not supposed to see because we measured a little off, just make it a bigger dot. That is my centroid. Okay? These two sides are the same, but they're different from these pieces. So I'm going to put a different tick mark on these three. I'm going to put 3 tick marks instead of 2 or 1. Okay? Let's look at the next one, the right triangle. So in my right triangle, we're going to do the same thing. We're going to measure our 3 sides. So I'm going to measure this one 6.8, which is going to be 3.4. And then I'm going to connect to the opposite side. And I'm going to mark congruent, 3.4 centimeters, 3.4 centimeters. I'm going to measure my top piece. Ooh, 6 centimeters. So 6 centimeters, that's going to be 3 centimeters. Different from the other one, 3 centimeters and 3 centimeters. And I'm going to connect back over here. And then my last side, when I measure my last side, it is about 3.1, somewhere in there, so it's going to be about 1.5-ish. We'll see how well it turns out. 1.5 centimeters, 1.5 centimeters. And when I connect, I should intersect right at the same exact spot to make my centroid. Right there is my centroid. All right, so it's on the inside of my acute, it's on the inside of my right, which is different from up here, right? We were on the inside of the acute, we were on the right corner of my right. So now, what we have left is our obtuse triangle. So let's do the obtuse triangle. Okay. So when I measure here, this one is 8 centimeters, so that's easy to divide in half. That's 4. Connect it to the opposite side. And mark it congruent. Congruent, they're both 4 centimeters. Measure this side. This side is about 9.9. So 9.9 divided by 2 is going to be 4.95. So almost at the 5. 4.95 is going to be halfway between the tick mark right in front of the 5 and the 5. There's my midpoint. There's my median. Now this was a different measurement. It was 4.95, almost a whole centimeter bigger. And so we can already see where our centroid is going to be. It's going to be inside this one also. So all of them were inside the triangle. But let's measure this last one and see. All right, we are at 3 point, let's see, that would be 5, 6, 7, about 3.8. So 3.8 divided by 2 is 1.9. Which is right here, 1.9 centimeters. And when I connect that back to my original point, hopefully it goes right through the centroid. If not, we'll fix it. Oh, it might be a little bit off. That's okay. We're human. So I have a little gap in there. That's okay. Nobody's ever going to know we have it because I'm just going to make a bigger dot. Okay? There is my centroid for my obtuse triangle. So I can see that no matter what type of triangle I'm working with, when I'm finding the centroid, when I'm working with the medians, my triangles will always, or my centroids will always be inside the triangle. Always inside the triangle. Whereas that wasn't so true for my orthocenters. Okay? In the next video, we're going to see how we work with the centroid and what type of questions we'll see when working with the centroid. Okay? Thank you so much for watching.